This last problem, I hope you already did it. This is just to check it. You should have gotten these decimals as your approximations. Notice that when I do the cube first, since 8 is an integer, when I cube it, I get an integer. So I don't have to deal with decimals and copying them down until the last step. So that's something to think about. All right, next page, example 1. So evaluate without a calculator. The first one is 125 to the third power, to the 1/3 power. 1/3 power, not third power. It's not cubing it. It's the cube root of it. So this is the cube root of 125. Plug it in your calculator. What do you get? Okay, next one, 1/36. I guess it wants without a calculator, but this is just a common one that if it ends in a 5, you know 5 goes into it. So if you did a prime factor tree, so I know 5 goes into it. 5 goes into 125 25 times. 25 is 5 and 5. Hey, look at that. So you can do prime factorization trees, and then you can see what number multiplied by itself 3 times will get you what you're trying to get. Since 5 times 5 times 5 is it the same number times itself 3 times, I know the cubic 1/3 root of 125 is 5, which would mean that 5 cubed has to equal 125. So if I wanted to show that this is the cube root of 125, then I would show this equation works. Okay. All right, next one, 1/36. Hey, we like these numbers because we want the square root of it. I can take the square root of 1 over the square root of 36 and do them separately. What's the square root of 1? What's the square root of 36? Boom, you got your answer. Okay, and then on C, it has a -16 to the 1/4. They don't have parentheses because they're trying to trick you. If there are no parentheses that are telling you something specific, the parentheses do not include the negative. So my answer will be negative because I just have a negative sitting out there. I'd click it, drag it down to my answer if it's on a computer. This is the 4th root. So I'm looking for the same number that multiplies by itself 4 times to end up with 16. Yes, you could do it manually by hand, or we can look at our factor trees. This is an example. So what multiplies to make 16? 2 and 8. Okay, what multiplies to make 8? 2 and 4. What makes 4? 2 and 2. What number at the end of all the branches on our tree do you notice is the same? How many are there? So our answer is -2. If I wanted to prove that this is the 4th root of positive 16 with that negative on the outside, I would be doing -2 times 2 times 2 times 2 and showing that -2 to the 4th equals -16. I guess you can't see that. There you go. All right, which method is simpler to communicate? This one that uses a radical sign or this one with an exponent? Please explain to yourself and to me why. Pause it, answer it out. The more you write and reflect, the more it's going to get stuck in your brain. So make meaning with yourself. Activity 1. So they want us to graph, and I'm just going to sketch it here, and it's also in your book, but I want you to sketch it. So x to the 4th, it's like a regular quadratic, but it's going to be a little okay, I want to graph it because I can't remember if it's more straight or if it's wider. I think it's wider because it has a multiplicity of 4, which means it gets more deep. But let's go see. I'm still in radians or something. No, I'm fine. I'm in function. Zoom standard 6. There we go. Now it'll graph it for us. Yeah. It's more of a U than a V. Okay, so that's f of x. And then the 4th root of x is going to be, might as well put it in here since I have it up, x to the, I can do 0.25. That is technically an exponent. It's the same thing as the fraction. So it doesn't matter. It's just the fraction. Makes a lot more sense in our brains because flower power, numerator will have your power and denominator will have your root. So it comes up a little more and then it goes over just as much. Those all have arrows on them because they continue forever. All right, and they told you the scale that they need to have your window on, so click window, and you can adjust that as necessary. I'm just sketching it. They also want us on step 2 to sketch the line y equals x. Why would they want us to sketch y equals x? What do you notice about our graph once you put that in there? What's the relationship between this part of x to the 4th and this part x to the 1/4? They're reflections. And what do we know about two functions that are reflections of each other over this line y equals x? They're inverses. So it's really cool that f of x being x to the 4th, and if we make g of x piecewise, so we do x to the 1/4 and we do a negative x to the 1/4, then this will give us this. And these are they functions? No. F is a function, g is not a function, but g of x does get us the reflection, and we can say they're inverses, they're just not inverse functions, inverse relations. All right, so that was the main thing about drawing y equals x. And then since x squared equals 9 gave two solutions, that's because you would go through and you would hit a positive solution and a negative solution. That doesn't make it a function, but you do get the two solutions that are possible. We don't know which answer is actually true in whichever circumstance, but we do know we get two solutions. Why does the square root function not show both solutions in the graphing calculator? I'll let you answer that on your own.